I'm ready for my headshot.
Alright, here we go.
Yo, Justin.
So, we're gonna continue here with the review. We're doing the rest of the multiple choice that we haven't completed. So let's try to see how much we can get through here, okay? So the first one says, which of the following statements can be made about the graph of h when x equals pi over 2? So how would I know if the original function was increasing, decreasing, had a horizontal tangent? What is going to tell me the answer to it?
If h prime of x is either positive,
The derivative, right?
or greater than 0.
So h prime of x is positive, or h prime of x is negative, or h prime of x is 0, right? Okay, so we need to figure that out. This is the calculator section. So can we use the calculator to get the derivative at pi over 2?
Yes.
Alright, so let's do it. Okay, I'm just going to go straight to the calculator page. I'm going to go to menu, calculus, derivative at a point, and I want it at pi over 2. With me? Yes. Alright, now you just got to type in that equation to see what it spits out. So ln of cosine of x divided by tangent of x. Press enter, and what does it give us?
Undefined.
Undefined. So therefore, is it positive?
No.
So is it increasing?
No.
Is it negative?
No.
So is it decreasing?
No.
Is it 0? No, so I don't have a horizontal tangent, so what does that answer have to be? No conclusion can be drawn. Okay? Number 2, consider the graph f of x to the right to determine which of the statements are true. Right? So is the derivative equal to 0 when x equals 3? So when I go to 3, do I have a slope of 0 there? What do I have here? A cusp. So is it even differentiable there?
No.
No, so this is false. Okay? Number 2 says that the derivative at 2.5 is greater than 0, meaning that it's positive. So if I went to 2.5 and I drew a tangent line there, would the slope be positive?
Yes.
Yeah. So is this true?
Yes.
On the interval -4 to 5, okay, so in between -4 and +5 only, there are 3 values at which f is not differentiable at. Is that a true statement? Where are the 3 values where it's not differentiable?
X equals -2,
X equals -2, okay, why there?
Because there's
There's
a
a hole.
There's a hole, meaning it's not what?
Continuous.
Continuous, okay, where else?
X equals 1.
At 1, because there's a jump, therefore meaning it's not continuous, and if it's not continuous, it's not differentiable. And what's the third one? At 3, due to a
Cusp.
cusp, okay? So the only ones that are true here are
2 and 3.
2 and 3, which would be letter A. Cool? If we had already eliminated number 1, right? We knew that was false. Which answer choices could we have crossed out?
B and D.
B and D, right? And then if I really wanted to make sure between C and A,
You just have to check number 2.
we really only had to check number 2, right? Because both of them had what? 3. So we didn't even have to worry about checking 3 because we knew it had to be true because it's on the 2 that are left over. Does that make sense?
Yes.
Okay, test taking strategies. Number 3. They give you all this information and then they want to know h prime of 7. So in order to find h prime of 7, I first need who? I need h prime, right? So how would I get h prime if I have the division of 2 functions? Quotient rule, right?
Yes.
So low,
D of X.
d high,
F prime of X.
minus high,
F of X.
d low.
G prime of X.
Alright. Over?
G
No squared. Pay attention, guys. Okay, so now we need to plug in what in there?
The values that they give you.
A 7, right? So we want g of 7 times f prime of 7 minus f of 7 times g prime of 7 all over g of 7 squared. So now let's look at the given information and replace the values. So what's g of 7? Make sure you look carefully. 1 times what's f prime of 7?
14.
14. You don't want to mess this up, right? Minus f of 7.
0.
0. Do I even need to find the second one?
No.
No, so no, it's going to be 0. Stop wasting time. Divided by g of 7.
1.
1 squared. This guy's always going to be the same as this first guy, right? Okay, so We end up getting 14 times 1, which is 14, divided by 1 squared, which is 1, so 14 over 1 is? 14. Easy? Number 4. The graph to the right shows data of a function h of t, which shows the relationship between temperature in degrees Celsius and the time in hours. Okay, so temperature will be on the y-axis in degrees Celsius, and time will be on the x-axis in what?
Hours.
Hours, okay? What does the value of h prime of 6 represent? So this is a what? As soon as you see that derivative,
The IROC, yeah.
it's an instantaneous rate of change, right? So what will be its units? It's like a slope, right?
Degrees per hour.
Very good. So the units for this guy are going to be degrees Celsius per hour, because we're finding a slope. So it's the y's over the x's. So it's the degrees Celsius over the hours. Does it make sense? Okay? So if I just plug something into h, what am I going to figure out? Like if I put in a 10, what am I going to figure out?
The degrees.
The temperature at that time, right? But that's not what I'm plugging something in. I'm plugging something into the derivative. So it's going to tell me the rate at which what is changing?
The temperature.
The temperature. Does that make sense? At that one specific moment in time. So looking at these choices, let's see which one's correct. H prime of 6 represents the temperature after 6 hours measured in degrees Celsius.
No.
No, it's not going to give me temperature. H prime represents the rate, okay, so we're on the right track, at which temperature is changing after 6 hours measured in degrees Celsius.
No.
No.
No, what messes that one up?
The
Per hour.
yeah.
The units, right? Dang it. Everything else was good? Okay. How about C? H prime represents the temperature after 6 hours measured in degrees Celsius per hour.
No.
It's not a rate. It's not a rate, right? It's not going to tell me the temperature after 6 hours. It's going to tell me the rate at which that temperature is changing, right? Rate of change. So it has to be letter what? D. And D is very similar to B. The only thing that changes is that it has the proper units. Cool? Right, number 5. The graph of h of x is equal to this, is pictured below. What is the value of h inverse of 6 prime? Okay, so what would be the formula to calculate this? 1 over
h prime.
H prime
H inverse of 6.
of 6. Okay, so in order to answer this question, we first need to find the value of this. And we do that by doing step 1, which is where we ask ourselves, h, the original function of what x, gives me that y value. Because it's a y value on the original function, since it's an x on the inverse. So when is this guy equal to 6? At 0, right? Make sense? So that's our x value. So now I want 1 over h prime of what? Not 6. 0. So step 2 is to find who? The derivative, right? So can we find the derivative of this guy?
Yes.
Remember, he's x plus 4 to the half, right? So let's do 1/2 times 2. What does that give me? 1 times x plus 4 to the negative 1/2, right? Times the derivative of the inside, which is 1, plus the derivative of 2, which is 0. So are we okay? All right. This can be rewritten as 1 over the square root of x plus 4. And what are we supposed to plug in there?
6.
No,
0.
0, right? We're trying to find h prime of 0. So put 0 in there in your head, and what do you end up with?
1 over 2.
1 over 2. And step 3 was to get the what of that?
Inverse.
The reciprocal, because this is going to be 1 over 2, which ends up being 2. You understand? Some kids are going to get this far, and they're going to pick what? D. Okay, don't forget that third step of getting the reciprocal if you're following the steps. Okay, if you're following the formula, you should be fine. Good? Number 6. Find y primes. That should be easy, right? What do I need to do to get the derivative of this guy?
Product property.
Product rule, right? So let's go. Derivative of the first?
2x.
times the second
Yes.
plus the first times the derivative of the second.
E to the x times one.
E to the x times 1, so basically e to the x. Right? E to the x dx. Yeah?
E to the x.
No, it's e to the x dy dx, e to the x dx. Remember? Okay, anyways. So, what do these two have in common that can be factored out so it can make it look like one of our answer choices?
E to the x.
One x and one e to the x. Okay, so what's left over? We're pretty much done, right?
2 plus
Hold on.
x.
2 plus x?
Yes.
Oh, that one's not there.
X plus
I mean,
None of the above, right? E? No? Oh, it's really the same thing as C? Oh, okay, cool. Some kids would freak out with that.
Really?
Yeah.
Write down your
You'd be
answer.
surprised.
Yeah, make your own answer choice. Alright, number 7. The function f is pictured to the right, and which of the following values of x is f defined and continuous but not differentiable? Okay, so it has to be defined and it has to be continuous, but it's not differentiable. So here we go, let's check all three things at 2. So at 2, is it defined? Can I go to 2 and touch the graph somewhere? I can touch it right here at the solid dot, right? Is it continuous?
No.
No. Okay, not continuous. So does it fail one of the three things?
Yes.
Alright, so that one's out. Okay. The next one, is it defined at 3?
Yes.
Yes. Is it continuous at 3?
No. Yes.
Yes.
You can just grab both sides.
It is continuous at 3?
Yeah.
It is.
It's
But
not
is it
different.
differentiable?
No.
No. Do we want it to be differentiable?
Yes.
No. No. It says what? Not differentiable. So is this a keeper?
Yes.
Yes. Okay, so let's get rid of everything that has a 1 first, right? So this guy's go away, B and D, right? And then we want to keep 2 because 2 was correct. Oh man, if we would have eliminated after this one, we wouldn't have even had to check 2, right? We would have just checked 3. But anyways, we already did it. Let's go to 5. Okay, at 5, is it defined?
Yes.
Is it continuous?
Yes.
Is it differentiable?
Yes.
Yes, but we want it to be not differentiable. So that means 3 is out, so the only answer is good?
Wow.
Yes, number 6. Alright, so now we're down to the last couple of minutes here in class. We need to decide which of the 2 free responses we want to do because we don't have time to do both.
Just do both. I'll skip third.
Let's take a
Grass?
Let's go with the
Or
first
garden?
one.
The first one, which is the one on this page, the one after 7. Alright,
Yeah.
wanna do this one?
Yeah.
The other one is similar to what we just did on Thursday and Friday of last week with the continuity and differentiability, so that should be kind of fresh.
Okay.
I don't think you should have problems with that.
Look back.
That will be on the test, so make sure you're ready. I don't remember if this is on the test. We can go over it anyway.
Go over the whole thing.
Alright, so let's see. The table below shows the values of differentiable functions f and g and their derivatives and selected values. Letter A. Approximate the value of f prime of 1.5. Thank you, sir. Approximate f prime at 1.5. So where would 1.5 fall? So I know 1.5 is right here, and I'm paying attention to f, because I want to approximate f prime. So what do I need to do?
Need to get the 2 points.
I need 2 points
Actually did this one.
close to 1.5 on what graph? On f or on f prime?
Or F.
F or f prime?
F.
F, right? When I get 2 points on f and I get the slope of it, that's giving me the derivative, right? Does that make sense? Yes? Kids always mess up and they get these guys, and they use these guys and they mess that up. So be careful. It's 2 points close to 1.5 on f. Well, if you use f prime, then you're getting f double prime. You're getting the second derivative. Because you're finding the slopes on the first derivative. Does that make sense?
Yeah.
Alright, so be careful. So let's do it. Okay, so we're gonna say f prime at 1.5 is approximately what? What are my 2 points that I'm gonna use? Maybe I should write them down over here.
1, 3, and 2.
1, 3, and 2, 5?
Yes.
Okay, so now let's do the slope formula. What goes on the top?
Minus 3.
5 minus 3.
5 minus 3, okay.
Over 2 minus 1.
Over 2 minus 1. Good, hopefully we don't mess that up. So we end up with what?
2 over 1.
2 over 1, so we get 2. Explain why your answer is a good approximation. Why would this be a good approximation?
Because you said sunset.
It sounds.
So this would be a good approximation because the points x equals 1 and x equals 2 are
Close.
close to x equals 1.5, right? That's it.
As long
I'm not gonna write that down, but you can write it. But that's the reason, okay? Easy? Now they're not entirely really close if you're thinking mathematically, but they are pretty close. If that makes any sense. They're the closest points that you can pick on the table that's given. Could we have used 0 and 3?
No.
Yes.
I mean,
We could have, right? But would it have been as a good of approximation as it would have using 1 and 2?
No.
No. Why?
Because